Hello to all the learners. So till now the tutorials have been in Hindi, but this Java tutorial is completely in English. And let me tell you guys that this is part 1 of the Java tutorial that will cover all the basic core concepts of Java. So let's get started. When I say Java is high level object oriented programming language, you guys will be like, and this is the reason I am going to start this tutorial right from the scratch, and I'm assuming that the viewers are completely new to programming. So don't worry about the terminologies. Let us start with the story of Java. So the story of Java begins with James Gosling and his team. James Gosling, Mike Sheridan, and Patrick Norton, these three engineers initiated the Java language project in June 1991. So these were the team of engineers working at Sun Microsystems, and they called themselves as a green team. Java was initially called Oak, and it was named after an oak tree that was standing outside their office. So oak is supposed to be a symbol of strength and durability, and this was the reason they named it as Oak. Now talking about James Gosling. So James Gosling was the head of the project at that time. And his ultimate goal was to create language with write once, run everywhere functionality. And this actually changed the software industry completely. Now, how it changed the software industry completely and what this write once, run anywhere means, you'll get to know in next 10 minutes. So the goal was set and now the design had to be made. So talking about the design and syntax, James kept the syntax of Java similar to C, C++. And this made it easy for the current programmers who are well familiar with C notations to get command on Java as well. So the learners watching this video who came to learn Java after learning C or C++ will know the syntax is very similar to C and C++. Now, talking about the project, the language was originally designed mainly for digital cable television industry to program the new generations of TVs with smart functions and various set-top box devices. Also, there were few name changes of the language too. So, Oak was renamed as Green for some time, and then one day, finally, when James Gosling was out for a coffee, he thought of an Indonesian island where the first coffee was produced, and this island's name is Java. So he planned of renaming it as Java in 1994. So in 1994, this finally happened. And after that, Sun Microsystem released their first version of Java, Java 1.0, in 1996. And then, till now, they are unstoppable. So, as you can see, these are all the versions that they have released all these years. Now, Sun Microsystems handed over Java to Oracle. So, Oracle Corporation took over Java in 2010. And since Java SE8 release, Oracle Corporation is following a pattern for their release of the versions. So as you can see over here, the even version is released in March month and odd version is released in September month. Now, let's go into few technical stuff, but before moving forward, I want you to assume this scenario. Imagine you go to Japan for a solo trip and you don't know how to speak Japanese. You're very hungry and you go to a restaurant and wish to order some food. But at the same time, you want to customize the dish a little bit and want to eliminate few items you are allergic to. But unfortunately, the people taking order at the restaurant know only Japanese. What would you do in this case? So I know some of you must have thought of Google Translate for translating English to Japanese maybe. And some of you might have thought of asking some other customer who knows Japanese and English as well to translate it for you. So yes, basically you need a translator for communication to happen, right? Another synonym for translator would be interpreter. So you definitely need an interpreter in this case to deliver what you want. Now, why did I tell you the story? Let's compare this with how Java works. Now, everybody watching this video knows that computer does not understand human languages and it only understands the machine language. So the machine language looks something like this. This is a function written for 32-bit architecture to calculate Fibonacci number, and this is how the machine language looks like. Can you imagine yourself coding like this? Definitely not. So, you need something to communicate with the machine, right? You know English, your computer knows this language, so there should be something in between to communicate with the machine. And what is it? Compare it with the Japanese example. Yes, you guessed it right. It's an interpreter. Java uses an interpreter to execute its program. So the interpreter scans code line by line and it converts it into the machine language. This is not how exactly the translation takes place. There is one more phase involved before the interpreter, but we won't talk about that right now. So, just to get a basic idea, just imagine the translation is taking place due to the interpreter in between. Let's get into this high level term now. So, coming to the word high level, for that, you need to see this diagram. As you see, machine language is at the lowest position and is near the hardware. After that, there is something called as assembly language. So the assembly language is a combination of little bit of English and hardware related registers and memories. So low level language or the assembly language is specifically structured to run directly on the hardware. But as you know that every platform or every architecture family is going to be different and it will have different assembly language set, which means that the code written for one might not run on the other, which in short means that code is not portable and is machine dependent. So low level languages are more appropriate for developing new operating systems or writing firmware codes for microcontrollers. So low level languages are definitely not fit for portable purpose. And this is why high level languages came into existence. So Java is a high level language and it is extremely portable and close to the English language. And mostly it is used to write software that can run on multiple platforms and architectures. So, to put this in the simplest way possible, high level languages allow the programmer to think about how to solve the problem and not about how to communicate with the computer or the computer's hardware. So, now you all must have got an overview of how high level languages work and why Java is one of them. Moving forward, you all must have seen and used various files with various file extensions. So the file extension which Java uses is .java. That means if you create a Java program, you need to save the file with .java extension. Now, coming back to the translation process that we discussed, I told you that the interpreter is used to convert source code to machine code. And I also mentioned that there is one more phase involved. So yes, there is something called as compiler between the source code and your interpreter. The compiler is responsible for converting the source code to an intermediate code called the bytecode. So imagine if I write a simple hello world program and save it with hello.java, it will first go through the Java compiler whose name is javac. So my javac compiler will convert this source code in an intermediate code called as the bytecode and saves it with .class extension. And this .class file is then given to the interpreter for the conversion of this bytecode to the machine code for execution. You must be thinking that there's so much work to do, but you need not worry about all this because Java has its own development kit that will do all the necessary translation for you. So you can simply download and install Java development kit depending upon the operating system and get started with Java program execution. Now let's check what exactly this Java development kit looks like. So as you see, the JDK has development tools and Java runtime environment. Now talking about the compilers, as I mentioned before, they accept the .java files, that is the source code developed by the developers, and it converts it into the byte code, that is .class file. We have something called as debugger also. So debugging is a process of finding and resolving bugs within the programs. It helps the developer to generate the error-free code, and this is what the debugger does. Now talking about the JRE, that is a Java runtime environment, it has a set of tools using which JVM actually runs. So as I told you before, JVM converts the byte code that the compiler has generated into the machine specific code. In addition to this, it also provides basic Java functions like memory management, security, garbage collection, and many more that we will discuss in the later section of this tutorial. In JRE, we also have libraries. So the byte code needs certain libraries for execution, and these are the libraries that JVM uses for running our program. Now let's discuss the entire process once again in short. So we write the source code which first goes to the compiler. The compiler takes the source code and converts it into the byte code, which is then given to the JVM for conversion into the executable code. So till now we have seen history of Java, high level languages and Java development kit. We won't install JDK right now because even a basic code in Java has certain keywords that we did not discuss so far. So keywords are certain reserved words in Java that are used for specific purposes. And that is the reason I am not going to start coding right now until I give you some basic idea of how a Java program looks like. So every program in Java has something called as class. You need to create a class for writing code in Java. Now what are classes? So a class you can consider as a blueprint that has two things. One, the variables or the data members used in the program, and second, the methods, or you can call them as functions that are required for performing various operations coming to the program. So for example, you can consider a calculator class. So number 1 and number 2 are the two numbers on which I wish to perform the operations, and these are nothing but the data members or the variables that I have given in my program. And add, subtract, multiply and divide are the operations I wish to perform on the data members. These are nothing but the methods. I would give you one more example of a mobile phone. So let's consider mobile phone as a class. So IMEI number, model number, color of the phone are the variables or the data members, and save contact, call, text or maybe play music are the methods. Now, every class is a collection of something called as objects that has characteristics and functionalities in common. For example, there can be many mobile phones as an object of class mobile phone. For example, Samsung, iPhone, OnePlus, these can be considered as objects of class mobile phone that have the data members and methods present in each. So now I can change the definition of class a little bit and say that class is a collection of objects that has common properties and methods. So here Samsung is an object which has these data members and methods of mobile phone class, and similarly this applies to iPhone and OnePlus as well. So now if I visualize this circle as a class, it is a collection of objects which has data members and methods in each. I hope I did not confuse you much. We'll talk about this much in detail later. Now I want to move forward to data members, or what we can call as variables. So to understand variables, we need to understand what are data types first. For this, I'll be starting right from basics. I want to show you this data, and now I want you to think what type of data this is. Now, coming to 1, this is a number, or we can call it as an integer. A is a letter, or in computer terms, you can call it as a character. Next, I've given you a word apple that has many characters which we can call as a string. So now, if I wish to store age, what type would it fall in? Yes, it is an integer. But this information is stored in our brain, and that is the reason we understand that this type of data, age, should be an integer. But the computer, or more precisely, I would say the compiler, is unaware about it. We need to tell the compiler about the data and the type of data we are using in our program. And this is what we call as a data type. So there are basically 2 categories of data types in Java: primitive and non-primitive. Let's talk about primitive data types first. So primitive data types hold single values of anything you wish to store. Now here, int is for storing integers. I will have to specify the data type along with the word age to tell the compiler that age is an integer. Something like this. So here int is the data type and age is the variable name. So this is nothing but variable declaration. So the variable name I am giving to the compiler to tell the compiler that I wish to store an integer and I need space for it, and you assign space for the integer and name it as age so that I can use it in my program. Here I've also written a semicolon after the declaration. So let me tell you that all the declarations and the non-block statements need to be ended with a semicolon. Don't worry about the term non-block now. Let's move ahead. Let's come back to our data types now. So starting with Boolean. So the Boolean data type represents 1 bit of information that is either true or false. For example, if you wish to make the page by default not logged in first and only allow the users after logging in, you can simply write boolean is logged in is equal to false. So is logged in is the name given by me. You can write it anything. You can write it A, you can write it B, you can write it logged, or whatever you wish. So is logged in is the variable name given by me for the data type boolean, and the value of it I have assigned as false. And I can change this value as true later when the user logs in. Now coming to byte. So byte you can consider as a smaller version of integer. You can use byte instead of integer where you need to store smaller numbers. So the byte range, it lies between -128 to +127. That is, the minimum value that you can store in a byte is -128 and the maximum value is 127. For example, byte A is equal to 10. So here 10 is the value which you've given to the variable A of the type byte. Now some of you might get confused with how I got this range -128 +127. So let me make this clear first. Let's understand this step by step so that you will understand the ranges of the other data types too. So understanding the steps, how the range is calculated. Now you all know that 1 bit can take 2 values, 0 or 1. Why? Because 2 raised to 1 is 2. Now 1 byte is 8 bits. Over here we have 8 bits in hand. So the first bit is used for the sign, that is minus or plus. So 0 is for positive and 1 is for negative. And now we have 7 bits where actual numbers can be stored. So that means we can write 2 raised to 7, that is 128 different numbers for every sign. I hope you're following this. So now we have 128 numbers for the negative side and 127 numbers for the positive side and a 0 too. And this is how we got the range minus 128 to 127 and also a 0 included in it. I hope you understood this explanation. I think you got a basic idea of how data types are and how the variable declaration is done. We can now speed up with the rest of the data types and move forward with coding in Java. So now coming to short, it's of 16-bit and this is the range which we calculated in the same way that we calculated before. And this is the example for it. And coming to integers, which is of 32 bits, and this is the range for it, and we can declare it in this way. Now coming to long, there is a difference. So here you need to write L at the end to tell the compiler that this is long and I need 64 bits to store this number. Now talking about numbers, you have 4 options. So depending upon where your number falls in what range, you can actually consider using that particular data type. If I wish to store a single character, I can simply write char followed by the variable name equal to, in single quotes, that particular character that I wish to store. So in this example, you can see char letter is equal to A in single quotes. This is going to store the letter A in my variable letter, which is of character type. Now coming to float and double. So these two can be used to store decimal numbers or the floating point numbers. And to store that, you just simply need to write the number followed by letter F for float and D for double. The size for all these data types you can see in this chart. So the rest default sizes I've already told you. Now coming to float, it takes 4 bytes of memory and double it takes 8 bytes of memory. Now these were all the primitive data types. Now coming to non-primitive data types, I would not like to discuss them right now because we'll be talking about them much in detail in the later section of this course. I'll just tell you how strings are declared and let's move to the next topic. You can simply write string variable name equal to the string I wish to store in double quotes. For example, string fruit is equal to apple in double quotes will store apple as a string in my variable fruit. So these are certain rules for writing variable names. You can just pause the video and see it once. We'll be talking about methods, but before talking about that, I want to cover a topic called as operators and then talk about methods. I'll be talking about the types of operators now. Let's start with the arithmetic operators first. So all these are the arithmetic operators in Java. In the last column, you can see we are performing operations on x and y. So here x and y are nothing but the operands on which the operations are performed. Now you must be knowing about the basic 5 arithmetic operations, that is addition, subtraction, multiplication, division and modulus. What some of you might not be knowing is about increment and decrement operator. So let us discuss about increment and decrement operators for some time. Now increment operators are of 2 types, pre-increment and post-increment. And decrement operators are also of 2 types, post-decrement and pre-decrement. If I write 2 plus signs before the operand, it is pre-increment. And if I write 2 plus signs after the operand, it is post-increment. Similarly, in case of decrement, if I write 2 minus signs before the operand, it is pre-decrement. And if I write two minus signs after the operand, it is post decrement. So basically, the increment operators are used to increment the value of the operand by 1, and the decrement operators are used to decrement the value of the operand by 1. Let's check few examples to see how they exactly work. Now here I've taken an example in which I've written a is equal to 5 and plus plus a. Now plus plus a, I told you this is a pre-increment operator. So what do you think will be the value of a? So according to the increment operator definition which I told you, it should be incrementing the value of a by 1. And yes, so the answer is 6. Similarly, if I write a plus plus and try to find out the updated value of a, this is also going to give me the answer as 6. Now, in case of decrement operation that I'm performing on a, what do you think should be the output? Yes, according to the definition, this should decrement the value of a by 1, and it is doing so. So the value of a is 4. Now you must be wondering if both the increment operator types are just incrementing their value by 1 and both the types of decrement operators are decrementing their value by 1, then what is the point in having types? And here is the answer for. Now let's take 4 examples and check all the 4 types much in detail. Now here I've written int x is equal to 10 and int y is equal to plus plus x. Now this is a pre-increment operator. So what do you think will be the value of x till the knowledge that I've given you? Yes, it will be 11. And what about the value of y? So here the value of y will also be 11. And the reason is the value is incremented first and then the result is computed. Now this was a pre-increment operator. Now consider this example of pre-decrement operator. This will perform in the same way as pre-increment. So here the value of x will be 9 and the value of y will also be 9. But now there is difference in the behavior in post-increment and post-decrement operations. Let's check how. Now here I've written x is equal to 10 and y is equal to x plus plus. Now what do you think will be the value of x and y? So the value of x is 11 and the value of y is 10. Now why did this happen? Because the variable's original value is used in the expression first and then the post increment operator updates the operand value by 1. Now here I've written x is equal to 10 and y is equal to x minus minus. So here I'm getting the value of x as 9 but the value of y will be 10. Now why did this happen? Because the variable's original value is used in the expression first and then the post decrement operator decrements the operand's value by 1. Now as a part of revision, let's fill up this table. So I want you all to assume a as 4, pause the video and try to fill up the final value of a and x. So now in the first row when I'm performing x is equal to plus plus a and assuming that the initial value of a is 4, the final value of a will be 5 and the value of x will also be 5. In case of x is equal to a plus plus, if the initial value is 4 of a, the value of a finally after this operation will be 5 and the value of x will be 4. And the final value of a in the third case when x is equal to minus minus a will be 3 and the value of x will also be 3. And in the last case when x is equal to a minus minus, the value of a will be 3 and the value of x will be 4. So the next type of operators are assignment operators. So we have used them before. while discussing the variable declarations. So if I declare int x and if I wish to assign the value to this, then I have to simply write equal to and give the particular value to that particular variable. Now here I've written int x is equal to 10, so equal to is acting as my assignment operator and is assigning the value 10 to the variable x. So in this table, I've given you some extra information in which the arithmetic operators are combined with the assignment operator to perform few operations. So here, x plus equal to 3 is equivalent to writing x is equal to x plus 3. You can go through the other operations as well by pausing the video. The next type of operators are comparison operators. So here in this table, you can see there are different types of comparison operators to compare the value of two operands. Now let me tell you one thing, the output of all these will be either true or false. That means these comparison operators, they return Boolean values. So if I'm trying to compare number 1 and number 2 in this example, then compare here is going to return false because number 1 and number 2 are not equal. Similarly, we can try and execute other comparison operators as well. The only thing you need to remember is these are returning values in Boolean form, that is either true or false. Now coming to logical operators, these are used to combine two conditions together. So the logical operator AND returns true if both the statements are true. For example, if x is less than 5 and x is less than 10 is going to return true if both the conditions are true. Now coming to logical OR, this returns true if one of the statement is true. So if x is less than 5 or x is less than 4, this statement is going to return true. And logical NOT is going to reverse the result and return false if the result is true. So if the inner bracket that you're seeing x is less than 5 and x is less than 10, if this returns true, logical NOT will give me the reverse result, that is false, as the output. Now consider this program in which I've written x is equal to 20 and I'm trying to compare the value of x in these conditions. So x here is less than 5 and is also less than 10, and so the output is true. Now actually in practical scenarios, nobody is going to try to print such Boolean outputs. Practically what we are going to do is use such Boolean cases of comparisons and logical operations in conditional statements like if. So in if condition, I mention one of the conditions, and if the condition turns out to be true, I will ask the compiler to run some block of code. So this is where we use logical and comparison operators the most. So we have also seen data types, variables and operators. So with this knowledge, coming back to our mobile phone example, can you think of what the data types of these data members will be? So coming to brand name, what do you think should be the data type? So the data type will be string. And what about RAM? RAM will also be string, and the reason is we have to write number as well as a letter. So in such cases, you need to have string as a data type. For example, string RAM is equal to 4 GB or 8 GB or 16 GB, whatever it is. And coming to IMEI number, so an IMEI number is 15 digits, so we definitely need long for this. And the cost of the phone, an integer, that is int, will be enough for it. Now let's talk about methods. So this is how a method looks like. So there's something before the method name, and after the method you have round brackets in which you can specify the parameters. Now if there are no parameters, you can leave it as blank, and after that within curly brackets you can write the lines of code which you wish to perform in that particular method. So basically, you have class in which you can write the data members and methods like I've told you before. So this will look something like this. So here I've taken a class calculations in which I have given two data members, number 1 and number 2, and I've written a method named add for performing addition. So I've not written the logic for performing addition, we'll see that later. But this is how a class in which the data members and method looks like. So within a class, you can have multiple methods and many variables you want. You can also have multiple classes with variables and methods of each. Now you all must have got these questions on your mind. From where does the execution exactly start when we have so many classes and methods? How will the computer know which class and method to execute? And what will the methods we wrote in the class do, and what will they exactly return? So I can answer the first question for you. From where does the execution start? For performing addition, like we wrote an add function or an add method, similarly, the JVM has a method called as the main method. So the main method is from where the execution begins. The JVM first searches for the main method and then starts executing the code from the main method. So here you can see there's something before it, and then we have written the main method. I have been actually telling you there's something before it. So what exactly this something before it means? So this something means to whom do you want to show this method to, and what type of data is this method returning? You'll come to know after we start executing the programs. So before I confuse you more, let me just summarize how a Java code actually looks like. So whenever I create a program, suppose my program's name is calculations, I am creating a class named calculations in which there is a main method through which I will tell the JVM what code has to be executed in what sequence. I can also have methods and variables of my choice in that class, or I can also create separate classes with variables and methods. Now we have enough knowledge to write the first code in Java. For that, we first need to install JDK and Eclipse. So I've given you the download link and the steps to follow in the description below. I want you to follow the exact steps and download Eclipse IDE for Enterprise Java and web developers. So there are two editions. One is the standard edition and other is the Enterprise edition. I want you to download the Enterprise edition because we'll be using the same Eclipse for the web development as well. I'm assuming that you all have downloaded and installed JDK and Eclipse by now. So the next step is creating a workspace. So a workspace is a place where your project files will be stored. For that, I'm creating a folder. I am naming this folder as the Concept Studio. You can give any name of your choice. After that, you need to open Eclipse IDE. Browse through the location of the workspace we just created and select the folder and click on Launch. You all will get this welcome page. You can close this and create the project. So for creating project, you need to go into File, New and Project. Select Java project from here and click on Next. Now you need to give a name to this project. I am writing over here Core Java as my name to this project and clicking on Finish. You can simply write here Don't Create and open Perspective. Folder has libraries and our source files. So we haven't created any file till now, and that's why the source is empty. Let's start with creating our first file in Java. So for that you need to right click on src, that is source, and select new class. So here you need to specify the package to. So package is nothing but where you can save similar files. So here I want to create a package named core where I can save all the core Java files together. So this is just for grouping purpose. I am naming my Java program as hello. I'm taking on public static void main for the main function and then finish. So this is how my Java program looks like. So I have the package at the top, package core, and I have a class named hello. So all the classes have capital letters. So it is a convention in Java to have class names with capital letters. I have a method named main, which I discussed before, through which the JVM will come to know from where the execution is taking place. I want you to ignore everything what is there before main and within the brackets of main for some time. And I am just going to type a simple program to print hello world on the console. So for that, I will write system.out.print and write whatever I wish to print. So as I'm typing, I'm getting options after the dot. So here I have print and println as two options. So print will simply print on the same line and ln will print on the next line. We can use any of this since I'm just having hello world as the string inside it. So I'll select any one of them and write hello world. And after clicking on run, I am getting hello world in my console. Like I told you that classes begin with capital letters. So here also you can observe system is starting with capital letter S. Like I've written hello as the class of our program in the core package. Similarly, system is a class created in java.lang package that we are using here. Println is a method over here that we are using to print whatever string we have given as arguments in the brackets. So here I've written hello world, and this way println method has helped me to print hello world on the console. Now I'll edit this program to perform addition of two numbers. So here I can write int number 1 is equal to 10, int number 2 is 20, and in int add I can simply add number 1 plus number 2. And if I try to print add, I will be getting 30 as the output in the console. I hope you got an idea of how the execution is taking place. Now, what I asked you to ignore, I will be discussing about them right now. So there is something called as return type that you need to specify before the method. And we need to specify parameters if required in the parenthesis. Let me take an example and show you the ways in which you can define methods, and also let's check out how objects are created and how the methods are invoked. So here I'm creating a file, new class, and I'm giving it as method return type demo. You can give any file name you want, and here I've forgotten to add public static void main, and that's why I'm writing main and clicking control space. So by clicking on control space, I got an option to select main. So control space is a shortcut in which you can complete the sentence or you can complete the statement. So here is the first way of writing the method. I have written here void as the return type. So basically void returns nothing. So as you can see over here, I have not even specified parameters inside the parenthesis. So whatever variables I am going to use, I will be defining them inside this method itself. So I'm writing here int num1 is equal to 10, int num2 is equal to 20, and I'm just printing the addition num1 plus num2. So now I need to create the object of this class so that I can call this add method. For doing that, I simply need to write the name of the class space the object equal to new and the class. So here what is happening, the new keyword, it allocates memory to this object and it returns the reference of that object to that memory. Now this object will help me invoke the methods and the variables which are accessible by this class. So now I can simply call the method by writing a.add. So if I click on run now, 30 is printed on the console. This was one way of writing the method. Let's check out the next way. So here in the first case, I had not specified any parameters. In the second way, I'll show you what to do if we need parameters inside the method. So here I've written void add int num1, int num2. And here I'm simply printing num1 plus num2. I need to tell that what is num1 and num2, something like this. So here I need to write a.add and specify what values I'm passing to the parameters of the add method that I've just written. So here I've given 10 and 50 as the values to num1 and num2 respectively. And now if I run this, here you can see 60 is printed in the console. So this was the second way in which I can create a method. So in the first two cases, the return type was void. A return type can also be a primitive type like integer, float or double, in which the method returns these type of values. Let's check out how. So here I'm writing int add me, and I'm not specifying any parameters. So here this method has to return a value integer, something like this. So here I've taken num1 is equal to 40, num2 is equal to 60, and I'm trying to return num1 plus num2. Now in the main method, I need to capture this returned value in a variable, and for that I am specifying int addition is equal to a.addme. So whatever value addme is returning, I am capturing it and storing it in addition. So if I try to print addition over here, I will get 100 as the output. So this was third way in which the return type was a primitive data type. Now let's try the same with the parameters in the parenthesis. I am writing here int add me and giving parameters num1 and num2. So here in the main method, we have to capture or take or store the addme's return value and also pass parameters to it. So here I'm passing two numbers as the values to the parameters num1 and num2. And I am taking the returned value in addition 1. I hope you're following this. And now I can simply write return num1 plus num2 and print addition 1. So here you can see 120 in the console. So these were the 4 ways in which you can write methods and you can use them according to your convenience. I already gave class name and method name in my programs, but there are certain rules that I want you all to go through. So class names follow camel case notations. That means the first letter is capital of each word we are using. And coming to method names start with small letters, that is lowercase, and then the camel case is followed from the next word we are using in method, like action performed. So here actions A is lowercase and the immediate next word used in that method, P of performed, is capital. So we discussed about return type that should be present before the method. There is something else called as access specifier also that you need to specify while writing methods. But let's keep this pending because I did not discuss about inheritance till now. Moving forward to the types of variables. Let me explain the 3 types of variables: local, instance, and static with an example. So I'll be creating a class variables demo and finish. I am going to declare few variables now. Int emp id, string emp name, and string company name. So all these 3 are nothing but instance variables. So instance variables are declared inside the class but outside the method. And to use an instance variable, an object of the class must be created. So before that, let me just create a method first, void print data, to print all these 3. So here I'm writing employee ID and printing emp ID and employee name and printing emp name and company name and printing the company name. Now let's create object of this variables demo class. So here I'm creating one employee, emp1, and I will be passing few values to the instance variables. So emp1 dot emp id is equal to 1, emp1 dot emp name is equal to suppose James, and emp1 dot company name is ABC. I have created one object over here and I've assigned values to the instance variables. And now I'll be creating one more employee, object emp2, something like this, and assigning values to it. So emp2 dot emp id is equal to 2, and company name as ABC. Now what I'll do is I'll just simply print these two. So for that I'll be calling emp1.printData and emp2.printData. Now whatever data is there in that particular object will be printed. So as you can see, employee 1's data is printed and object emp2's data is also printed. Now suppose my assumption is that all these employees belong to the same company. So if the company name is same, why are we actually assigning them using instance variables? Instance variables are only specific to objects having different values. So what I can do here is I can keep employee ID and employee name as the instance variable, and what I can do is make the company name as static. Now what this static will do, the company name will only be initialized once. So here I'm just declaring it and showing you how the value can be changed. Actually, the static variables have to be defined in the beginning so that all the instances can use them. So now since I've not defined and given any value to my company name, the JVM will assume it as null. So now to explain you how this is exactly working, I'll just comment out one of the values that the object was assigning to the company name. So I've commented out emp1's value, and now you can see that in both the cases company name is ABC. If I try to change it to XYZ, both will get reflected. So now there is no need to refer the static variable using an object. You can simply write the class name and change the value of the static variable this way. So this was all about the instance variables and the static variables. Now talking about the local variable. So a local variable is nothing but whose scope is within that particular method. So the scope of a local variable is limited to the method it is declared inside. Now if I write here int salary and give it a value of 20,000, I cannot access this salary outside this method. I can print salary inside the method itself. If I try to access it outside the method, it is showing me error. Now everybody take a while and think, what if salary is same for all the employees? What do you think, should I be making changes in my code so that the salary, it remains common to all the instances of my class? I hope you all must have thought of making the salary as static and assigning the value of salary as 20,000. Something like this. So these were the types of variables. Now I want to give you a rough idea about how this works at the memory level. So we know that the JVM's work is to load the code, verify the code, and execute the code. At the same time, it is responsible for managing the memory. So if we only focus on the three major areas inside the memory, it is the method memory, the heap, and the stack. So the method memory is used to store the class structures, the superclasses name, interfaces, and the constructors. And coming to stack, whenever we call a new method, a new block is created at the top of the stack which contains the values that are specific to that method. And it also contains the references to the objects. And talking about the heap space, so it is used by JVM to allocate memory to objects. So whenever we create an object, it is created inside the heap space itself. Now we can ignore the method area because before the Java 8 version, static variables of the class were stored in the method area of JVM. But after that, static variables are stored in the heap. So let's eliminate the method area for now and just focus on the heap and the stack space. Let's see what exactly is happening here. Consider this code without static anywhere. So here when I create a reference variable e1, it is first pushed onto the stack. When we use a new keyword, the JVM creates an instance for this object in the heap. Now this e1 will simply point to the object 1. If I create another reference variable e2, it is also pushed onto the stack, and after we write new, an instance of this is created inside the heap as shown here. So now, as the company name is same, we can share this with all the instances of classes by making the company as static. So here, when I add static to this, the scenario is something like this. So static variable is initialized in the heap memory only once, and it is common to all the instances of class as shown here. So all these topics I've covered in this particular section, and this was part 1 of the core Java tutorial. I will be covering object-oriented programming concepts and a few topics in the next part.